Welcome back, everybody. We're doing triple integrals. This is Calculus 3. Let's just jump right into it. Now we're going to look at I like to call them non-trivial boundaries, like rectangular boundaries. They're just trivial, easy to do. Previously, we looked in the double integral when y was a function of x. We can still have y be a function of x, but now let's look at where g is a function of x and y. And we've got a bottom boundary and an upper boundary for z. Previously, we showed doing this where we separated out the integral like this when we did y was a function of x like that. We were able to do that. Here, this is just like doing g1 to g2 for z, doing z first, and then we do the rest of the integral. So it's no longer a dv because the dz's out. We just got dA. I think it's a little easier if we dive into an example. Let G be the wedge in the first octant bounded by x squared plus z squared equals 4, y equals x, and y equals 0. So let's take a look at it real quick. So we got x squared plus z squared equals 4. That makes a cylinder. Remember, it goes all the way over. X squared plus z squared equals 4 is a cylinder. Like a toilet paper roll going along the y-axis. And we are doing from y equals x, so right here, y equals 0, and where z hits the boundary right here is x, so we're just extending. This is the edge of the tube right here. That's the edge of a tube. This is the edge of the tube as well. So what's going on in terms of our integral? If I write z, we had x squared plus z squared equals 4. I can write z as square root of 4 minus x squared. We are only doing the positive one because we're above the xy plane. So we don't need the negative one. So 0 is less than z, less than 4 minus x squared. We can see that then we're doing 0 to x for y. Y equals x. And then we'll integrate x. X goes from 0 to 2. How did I figure that out? Plug in z equals 0. Here z equals 0. So x squared plus 0 squared equals 4. X equals 2. Okay. So we set up our integral. And we wanted to find the triple integral for z dv. So we're going to do dz first because it's a function of x. Then we'll do dy because it's a function of x. And then we'll do dx. So 0 to 2, 0 to x, 4 minus x squared root of 4 minus x squared. I don't think I need that up anymore. Because all of this is basic stuff now. I can't separate it because I got to go in order. So we've got 1/2 z squared. We're evaluating it square root of 4 minus x squared to 0. I got the 1/2 out front. We integrate 4 minus x squared with respect to y, and we just got 4 minus x squared times y. Evaluated from 0 to x. That throws another x in as a multiplier, so 4x minus x cubed. We still have the 1/2 out front. This gives us 2x squared minus 1/4 to the x to the 4th. Still got the 1/2 out front. We're going from 0 to 2. We evaluate it. We get 2. That's it. You just got to be patient. Make sure you set up your limits of integration correctly. So we did from 0 to z, and z was square root of 4 minus x squared. Then we did 0 to y, and y equaled x. And then we did our x value. Okay, peace.